Hello, welcome to my channel. My name is Ansha. In this video, we're going to deal with initial and terminal point of vectors. Good. Okay, so this is just a continuation of our lectures devoted to vectors. Okay, so here we would learn how to use maybe 2 points. If given 2 points, where one is the initial point, that is the starting point of a vector, and then the other is the terminal point, that is the ending point of a vector, we can use those 2 points to determine the given vector. All right, good. So maybe let's just of course, from what I've just explained, you could understand that initial points are just the starting point of a particular vector, then the terminal points are just the end point of the vector. All right, so let's just simply do an example. Okay, so for the first example, I'm going to just give us the points. They want to determine the coordinates of the vector, right? Okay, so this is like example 1. Okay, so let's complete this. It starts somewhere up to somewhere, of course. So let's say this is the starting point and it's given by 2 on the x-axis. If you trace it to the y-axis, you also get 2. Then this is the end point of the vector. So let's put a little arrow to denote that. That's the end point. Then it starts from, or you trace to the x-axis, we get 4. Trace to the y-axis, we get 6. Good. So that's our vector right there. But we don't know the coordinate. That is to say, if we call the vector v, okay, so we want to find, let me put it here, we want to find vector v. Good. So this is vector v, but we don't know what the entries of that vector is, or what the entries are. Okay, so that's why we are dealing with this. So this is the initial point and this is the final point. So you want to find v in this form, a and b, where a and b are real numbers. So what we simply have to do is to take the difference. So given an initial point and a terminal point of a particular vector, then the vector is given by the difference between the terminal point and then the initial point. So let me just put it out there as something you should know. That a vector, so there's a given. Now, it's not really the difference, so to say, but in quotes, we can think about it as a difference. So I'll just say in quotes, right? So it's going to be like, in quotes, initial point and then terminal point. So let me use TP for terminal point and then IN for initial point. So if we take this difference, we should get the vector itself. Okay, so let's see what this will give us, coming back to this example. So we know that the final point here is 4, 6, right? So we say the vector v, that is the work, will be, or should be, of course vectors are represented by that, but in this case it's going to be this point minus this point, and we know how we subtract a point. We'll take the x coordinates, subtract them, and then subtract the y coordinates. All right, so we say 4 minus 2, that is x2 minus x1, something like that. So you put 4 minus 2 right here, and then 6 minus 2, so we say 6 minus 2. So this becomes 4 minus 2 is just 2, then 6 minus 2 is 4. Good. So this is the vector. This vector right here is exactly equal to the position vector from 0 to this point, from origin to this point where x is 2 and then y is 4. That's what that simply means. That the position of a vector doesn't matter. All that matters in a vector is the magnitude, that's the size, and then the direction, right? How it is, where its position doesn't really matter. So we can push it around and then the result will still stay, or the vector will still be the same. Okay, so that means this vector is the same thing as this vector. Now in this case, I've ignored the maybe what we should call scale, where I don't take the same centimeters, the same unit for each centimeter. That's why it seems as if it's longer in this case. But the idea is that given this vector, or this unknown vector, given the terminal points and the initial points of that vector, we could easily find the vector itself right, in position form by just taking the difference. Okay, let's just do another example real quick. So for the second example, it should be more like a word problem. So we say find a vector, maybe let's call the vector W, if the initial point of the vector is given as 3, 1, and then the terminal point is given as that is terminal point of that vector is given as -1, -2. Good. So we want to visualize this. So we want to visualize that. So we have some negatives there, -1 and then -2. So maybe let me bring it outside a little bit. Okay. So we have 3 and 1. So that's about right. Good. So for the initial point, we have 3 on the x-axis. So if we call this 1, we call this 2, we call this 3, we call this -1, call this -2, we call this 1, call this 2, call this 3, then call this -1, call this -2, and so on. Okay, so I don't really want to bother about the x and y's, all right? So this is 3 on the x-axis, is somewhere here, then 1 on the y-axis. So the point, the vector W, let me use blue for that, should be somewhere here. That's the initial point. Then the terminal point, -1, -2. So that will be -1, -2. So something like this. All right. So this is the terminal point. So we could connect these two dots and then take this as the terminal point. So the vector starts from 3, 1 and goes down to -1, 2. So this is the terminal point, this is the initial point. Okay, so that's the vector W, but we need to know the entries of this vector. So what we do is to simply take the difference. So we say the vector W is, of course, put in this form. Then we now take the difference between the initial point and the terminal point. Of course, this will give us the same vector, but in a different position, like I showed you earlier. It will be from the origin this time, but again, it doesn't matter. It's immaterial. Position of vectors is immaterial. In this case, we don't bother about it. Okay, so we say terminal point minus initial point. So I'm going to put some computations there. So we'd say for the terminal point, we have -1 minus 3. That's picking the x entries. And then we take the y entries, that'll be -2 minus 1. Good, so we take the difference between those two and then that should give us that. Okay, so let's see what this would be. -1 minus 3, that's -4, and then -2 minus 1, that's -3. Good, so that's the vector W, which we can visualize it this way by simply starting from the origin. So we'd have something like this. -3, -4. Maybe let me bring it out here a little bit. Okay, something like that. Then maybe something like this. So we search for -4 on the x-axis should be somewhere here, -4. The -3 on the y-axis should be somewhere here, -3. So we can fix the point around this, and then take the line from the origin. Okay, so that gives us that. So as you can see, it looks like it has this vector has the same direction as that, and of course that's true. So that's the vector W. So like I said, all that happens here is just changing position, which is immaterial for vectors. The direction and the magnitude stays the same. So this is how to get the vector itself given some points, initial points and terminal points. Okay. Alright, so this was a short one. In the next video, we're going to learn something very important about addition of vectors. So let's move right into the next video. And if you're not subscribed to my channel, please do well to subscribe to my channel, and we'll continue from there.